The CIS critical security controls provide a prioritized path to improve an enterprise's cybersecurity posture. Version 8 includes some exciting updates to keep up with the ever-changing cyber ecosystem. The CIS controls are now task-focused and combined by activities rather than by who manages the devices, decreasing the number of CIS controls from 20 to 18. The 18 controls contain 153 safeguards, which you formerly knew as subcontrols. Safeguards are still prioritized into implementation groups, or IGs, with IG1 defining essential cyber hygiene. The updated CIS controls point to existing standards and recommendations, along with V8, supporting information, products, and services are updated and available to help you with implementation. Learn more about CIS Controls version 8 by visiting CISECURITY.org/controls.
Podcast with your host, Chris Glandon, serving cybersecurity straight up with no chaser. Let's hit the bar and grab a drink.
Kyle, what's going on, man?
Yo, what's up, Chris? Not much. My damn phone is still giving me problems. I can't get on the web, and when I finally connect, I keep having other issues.
Damn, man, that sucks.
I know a guy who's about to walk in who will know how to get me connected, though.
Okay, cool. Well, in the meantime, let me get a drink.
You got it, Chris. But it's going to be a quick shot called Hologram. 1 part blue carousel, 1 part banana liqueur, and 1 part cranberry juice. Place the ingredients into the shaker with ice, shake, and strain into a shot glass.
Thanks, man. Hey, is this your guy?
Yes, sir.
Hey, that's my web guy. So when I finish my conversation with him, I'll send him your way.
You know where to find me. I'll see you next round.
I'm here with 3 gentlemen deeply rooted within the realm of security, data science, and the digital ecosystem. First, we have Mike Elkins. And for those that don't know Mike, he is not only on the Barcode team, but he's also a top-performing technology evangelist and a true veteran in the IT industry. What's going on, Mike?
Hey, what's going on, everybody? Happy to be here.
And next, we got Rohan Light. Rohan has been on Barcode previously, but besides that, he's also a true virtuoso at data perception, AI, ethics, GRC, and beyond. Rohan, welcome back, my friend.
G'day, mate. Glad to be back.
And also joining me is Charlie Northrup, co-founder of NeurSciences, a software technology, architecture, and solutions development company that provides their artificially intelligent digital brain applications to integrate, manage, and automate the things that truly matter to us. He is also laser focused on the digital transformation of the web into an ecosphere of ecosystems operated by and for the benefit of intelligent agents working for individuals, households, and organizations. So, Charlie, thank you so much for stopping by Barcode. It's an honor to have you join us.
It's my honor, man. This is going to be a lot of fun. I'm looking forward to it all day.
Cool, man. So, fellas, I'd really like to get into investigating and looking into what is known to us as Web 1 through Web 5, and with that, the emerging hyperconnected world that follows it. And I think in order to level set and get the conversation going, we should define Web 1 through Web 5 to truly understand the eras that they were born in and how that evolution occurred. So I guess it started back with like Web 0.0, right? With the invention of the web by Tim Berners-Lee. Or you can make the argument that it was Al Gore. right, Mike? So let's talk about that. And then, shortly after that, I guess the official Web 1 era was born. So, what exactly happened and how did Web 1 become a thing?
Oh, Charlie's taking that. Come on. I mean, I have one story from this era. One story. Email put me out of a job. I used to deliver mail. I was a mail boy. See, and then this email thing came along and took over. It was a nightmare.
Well, I think when I look back at this was at the time I was working at AT&T Bell Labs. And so I was in the Murray Hill Research Center, which was like the coolest environment that you could ever work in at that time. There was so much theoretic research still going on. And it was fun. And I remember walking into a researcher's office and he showed me Mosaic 0.8 or something. It was one of the early versions of Mosaic. And I was like, what is that? And he said, oh, this is called a World Wide Web browser. That's what it was back then. It was like a World Wide Web browser. And I was like, well, what do you do with it? Oh, we share information. We share documents, research papers with each other. And the more he explained it, I was like, oh, they're going to so commercialize this. And he said, no, it's for academic purposes only. Like that was the mindset back then, that you weren't supposed to commercialize it. It was really intended just for document sharing. But it was a stateless system, right? So back in even from 1990, even when I got involved in 94, there was this amazing system, but it had no state, right? There were cookies weren't defined yet. Right? And so you have to think about, like, to me, that's the original web browser or the original Web 1.0. That was the stateless system just for sharing documents, and everything was considered free. Right? That was the big deal.
Yeah, and at a much smaller scope, right? I mean, was it publicly available yet at this point?
Well, it was primarily distributed through research. So if you're in the research area or if you're in academia, you could get a web browser and start running it. Okay. And even though it was developed originally at the University of Illinois, what happened was that there was as the specs started to appear, people started creating free versions of it and they were selling their version of it. And so people now suddenly were able to get their hands on a web browser, especially once it was ported to Windows. That was a big deal, right? Because remember, back in the early 90s, everybody had Windows. And so as it started to get moved over to the Windows platform, more and more people started jumping on it. But so this is Web 1. Now, I have to clarify, because Mike asked the question earlier about Al Gore. Did Al Gore invent it? And people misquoted him quite a bit. And I think, for the record, it is fair to say that Al Gore helped to get the grant money for the university to really push the development of the web. And he also was the one who was out there touting the benefits of the web. Right, but it was the internet. Right, back then he called it the information superhighway. If you look it up, you can still find that reference.
For sure,
it was called the information superhighway, and he got it into the White House when Clinton Gore went into the White House. He was the one who bought it with him, and then he got the UN on email. So he did a lot to help promote the benefits of the web, without a doubt. Nobody can deny that. But that was still web. We were still at Web 1. We were stuck there.
I mean, now he would be better known for his climate work, right? I mean,
yeah,
a bigger problem. He's a good opener of problem solving.
So then the next big shift came when I think there was, I can't remember the name of the company. One of the companies wanted to do e-commerce over the web. And I think AT&T was actually the very first company that did a banner ad, right? No, or was it Pizza Hut? It was one of the two. It was either Pizza Hut or AT&T. But the very first banner ad was the most successful banner ad in history because it basically said, you don't want to click on this, but you know you will. And it was something silly like that. And everybody started clicking on it, and it was a hyperlink to another site. And suddenly it was this idea of selling ads on the internet became a thing. But what they didn't have was they still didn't have state, right? So state was the big game changer. And the other thing you have to remember, this is really super important. In the early days of the World Wide Web, you weren't ever intended to be a member. Right? That's something that most people don't really think about. And that matters. And in the end, that's like one of the biggest deals because it wasn't built with a membership model. It was intended that you would be a client and you would connect and you would exist inside somebody else's domain. But you were never intended yourself to be represented in the web. Right? You had no digital twin just for you.
Right. So there was no concept of reifying into digital space in that sense.
Yeah, none. You were only intended to exist inside somebody else's domain.
So would that really be considered more of a network of networks in that case? Meaning you have smaller private networks that connect to a larger connectivity of public networks?
Well, kind of, but you still are stuck in the sense that your point of presence inside the web was always stuck inside somebody else's domain and you couldn't escape out of it. Right? You could leave that domain and go to another domain.
Okay, you were fully sealed within it, in other words. That was essentially a fixed, finite, fully controlled space. Okay, wow. Interesting. Yeah.
And you had no agency. The only thing that you could do is whatever the website allowed you to do.
So that would be bubbles within bubbles. And as you say, the only functionality is 100% prescriptive guided. There was, once you entered that pipe, you were going to come out the other way, the other end in a completely known way.
So then they said, okay, so let's see if we can solve this. But it was because Mark Andreessen left the university and joined up with James Clark, and they were going to start a new company. And originally they were going to develop some kind of a PlayStation or something like that. But they ended up taking the license for the World Wide Web browser and server, and they started commercializing it. And this is when it started showing up on those 5 1/4-inch floppy drives. Remember?
So how did they commercialize it? I'm just curious how they pushed that.
Well, they got the license for it, right?
Okay.
So they went to the university. It was like $1 million. I think it was through Spyglass Inc., which was their monetization engine for the university. And so you get a license, and it could be wrong in the million, but it's something like that. That gave them the right to start distributing it. And they called it the Mosaic browser. And then the university said, oh, no. We own that name. You got to come up with your own name. And so that's when they came out with the Netscape communicator. That's how that started. You'd get the floppy drive and you'd put in your Windows box and you'd start up the web browser. But what Andreessen's team did, which was really, really cool, was they added cookies. They called it magic cookies at the time. And they added this idea that because you were never intended to exist inside the web, what they would do instead is they would allow the server to set cookies at the browser side. And so that the next time that you went to that same website, it would already know who you are. And that was the most significant change to the web suddenly, right? That was a big deal.
Would that be more of the identification of the end user on the other side and tracking of that?
Yeah, it started to allow for this idea that you could enter in a username and a password, and it could track you and know who you are. All right, so this was the 96, 97 timeframe But by 96, you have to remember too that Microsoft and Netscape, they were already in this browser war, right? So there was this war that was starting, the early browser war fight. And then it was found out that Netscape had magic cookies. And the Financial Times ran an article about it and said, that this could be a huge privacy problem, that this idea of cookies. And so I think it was the FCC got involved in it. I'm pretty sure I think it was the FCC got involved. There were government hearings about, oh my gosh, what's going to happen with these cookies? And back then, the early browsers suddenly had to have this box that would pop up and ask you if you would accept cookies, right? And so this was like 1997, 1998. That's when the IETF came out and said, here, we're going to make a standard about cookies so that everybody follows the same standard. And it was a big deal, but then it was like, okay, cool, we can have cookies and we can log in and remember who we are. But every time we'd go to a website, that stupid friggin' box would pop up. And people got so annoyed by having to say, oh, yeah, I'll accept them. Yeah, I'll accept them. Yeah, I'll accept them. It just became the default over time.
Yeah.
But if you go back to 1997, that's a funny thing. That original spec from the IETF, that was GDPR compliant before there was even a GDPR.
That's why I asked my follow-up question, because as soon as you started talking about 96 cookies and kind of tracking, and I was like, this isn't new. This is not anything fresh. Like GDPR and the California version of GDPR, like this is all, old hat, same song and dance.
Yeah, that rings true, eh?
But what's interesting, so I call that Web 2 because that was a significant moment in the web. And everybody has their own definitions of Web 1, Web 2, Web whatever. But to me, that was a significant difference. Stateless document sharing to suddenly, boom, you've got a stateful e-commerce platform. That's huge. But what you also saw during that transition was the end of free. That was a big moment.
So if I kind of look at lineage of some internets that kind of highlight Web 1, 2, and 3. Web 1, they consider a read-only web. Web 2, they kind of consider more of a social version where you're more read and write. Web 3 is where I think you're kind of hitting this point of where things stop becoming free, which is where it goes read, write, and execute, where we actually are starting to not just read the data, consume the data, but manipulate and do things with the data.
So if you look at the W3C's role in standardizing the web, right, and I look at their definitions, so they never really had Web 1, Web 2, but they did have their own version or their own idea of what would be Web 3. So there's the technical side of the development and change of the web, and then there's the marketing side, right? So marketing has a tendency to think of Web 2 as more around the social media, read and write kind of thing. But it really wasn't that, to me, it isn't that you could read and write. It was that you had state. Because if you didn't have state, you couldn't do anything. And it was really the e-commerce side of it that was starting to drive, that suddenly you could monetize.
Can I just clarify, when you say state, do you mean the sovereign entity, a state, or a system state?
A system state, meaning the use of cookies.
Got you.
Right? Because suddenly now you could do a shopping cart. Without cookies, you couldn't do the shopping cart. And so that was, to me, you couldn't even have social media sites like the way we think of them today if you didn't have that ability to have.
So the cookie is like a bridge, but actually to build the bridge, you also had to build the other side first. you actually had to create something to span to. And that was the genius of it. And no wonder it got commercialized and well financialized, because, of course, if you say 97, 98 was that cutover period, Well, 2008, 2009 is the global financial crisis, and over financialization of badly datafied data was a big part of that, right? I mean, it crashed within 10 years, that early model, even after surviving the dot-com bust.
Right. You remember that back then they were paying people like $75 an hour to sit there and write HTML. That was crazy time. You get paid. I mean, in '97, that was good money. You were getting paid good money to sit there just to write HTML.
Yeah. The late 90s were surprisingly tough, I think, for many. So where were you at this time, at this sort of shifting point, Charlie? What was your trajectory like?
So from around 97, I left AT&T Bell Labs and I went off on my own. And the reason I went off on my own was going back to 94 when I first saw what the web browser was. I decided that I was going to go home and start writing my very first patent. I've never written a patent in my life, but I was going to write a patent about this idea that you can change the world differently if you think of HTTP as just an access method. And so I got to explain just a little bit more that around the same time, I had met a researcher named Rick Rear at AT&T, and he wrote a database system called Daytona. And Daytona could handle a terabyte of data in 1997 faster than Oracle could. And it was this incredible system that he developed. And I thought, wow, this is cool. I want to read and learn about it. And in his manual, he introduced a data type called thing. And it floored me that anybody could come up with something as generic as the word thing as a data type. And that set me down this long journey along the way about what is this idea of things and how does that impact the way we think of computer science. So I had stopped and said, you know what, I got this crazy idea that you can move the protocols outside of the application, shove them inside, and suddenly we would be able to just say it's an access method. We don't care how the access method it works. And I put together a first patent application and filed it by 1997. I got my first patent, and I turned that into a patent portfolio of about 10 patents, which became a really cool defensive patent portfolio. And then I sold it off in 2007, and then started on my next part of the journey, which is where I'm at today. But before we get into that, I want to just wrap up one thing about Web 2, 3, 4. Okay. So we had Web 1 stateless, Web 2 suddenly has state. What is Web 3? In 2007, the W3C had come out with their own idea of what Web 3 would be, and they actually called it Web 3, and it was Web 3 or Web 3.0, and it was a semantic web. And Tim Berners-Lee started on the journey of the semantic web, but it never really took off. And it wasn't until 2014 when Gavin Wood, through Ethereum, came out and said, hey, you know what, we could develop a new Web 3, and it's going to be Web 2, the stateful web, blockchain, and smart contracts. And so that became this new idea, a redefinition of Web 3. And since that time, people have been redefining what Web 3 really means, just because they can.
Was that the first time an actual label was applied, as in Web 3?
That was 2007 by the W3C. There was actually a PDF you can find online with that reference.
Okay. Yeah, I was curious when the numeric value, Web 3.0, 4.0, 5.0, when that label was applied.
I don't know when they actually started labeling it, but okay. I do know that Gavin Wood, he had a really good intent in trying to say, hey, there's a different thing that we could do, and that's that we should we should think about the blockchain and smart contracts as being part of the web infrastructure. But it wasn't a W3C sponsored thing. And as a result, it really became more about marketing, right? And so when you look at what was the underlying problem that he's really trying to solve, right? That, to me, that's the most important thing here. What's the underlying problem? And the underlying problem to me was that Web 2 inherited Web 1, Web 3 inherited Web 2. Whatever Web 3 is, it's going to inherit whatever the limitations of Web 2. So the bottom line is you're still not a member of the web, right? And that's the fundamental issue here, is that the web wasn't built with a membership or a citizenship model. And so you're not part of it. You never were intended to be.
Charlie, let's unpack that for a moment. So you spoke a little bit about kind of being stateless or stateful earlier in the prior versions, but yet we as individuals right now, from what I'm understanding and learning here, is that we don't actually have any presence in the internet. We're stateless in the internet, even with Web 5, Metaverse, some of these other things. We as humans don't still have a presence. Like, help me understand a little more of this.
So the way the web is designed is a client-server model. And so you don't have in order for you to be represented in the digital world, you need three things at a minimum. You need an identity across domains. You need an agent, a sense of agency where you can control the exchange of value between domains. And you can decide how you want that exchange of value to occur. And you also need a digital home for your agent. So it has a place to store your stuff, the stuff that you own, the stuff that is all about just you. So when you look at the role of blockchain is more about saying, I can use a blockchain to cart my stuff into a website, into a domain, to say, hey, I'm here, this is all my stuff, and I can prove it, right? I have the key, so I can prove that this is my stuff. Well, it's good as long as that domain accepts that particular blockchain. But if it doesn't accept that particular blockchain, you have to leave your card outside. It doesn't do you any good. And that's because there's no standard around all of this yet, right? So that's really, but then you say, why do I even have to do that? And the answer is because you're not a member. You don't have an identity across domains. You don't have any sense of agency, and you don't have a home to store your digital stuff.
No, we're still acting through web browsers, end user devices, mobile laptops, phones, iPads, whatever, but it's still not a direct connection between human and the internet with some sort of identifiable way. It's probably a good thing.
Well, when we become members of the web, it changes everything, right? And it isn't just the web. So we refer to it as when you become a member of the digital world, that changes everything that we know. Think of, you have an agent inside the digital world and it works just for you. So what would you do? Well, I'd go out to dinner, take a picture, and I would tell my agent, share this with my friends and say, haha, suckers, I got to go to dinner. You know, like what you would do on regular social media. Take a picture of the kids and say, hey, agent, send that to my parents, or send that to, my brothers and sisters or whatever. And all of a sudden, what you start to realize is that your agent becomes the core of the social media. Yeah. Right? It performs the job of what we know as social media today.
Yes, that's going into the digital intermediary idea. And I think this is where I'm starting to come in now. It's around 2017, and over here in New Zealand, we were looking at how to obtain and maintain self-sovereignty, as it were, in terms of trust, inclusion, control, pretty important basic things. And we kept landing on the necessity of a skilled interculator. someone as a go-between or something, and then at the time the conversation was increasingly drifting towards AI, and so the AI, the blockchain, i.e. Ledger, which is a familiar financial tool, they started to gel and come together quite pronouncedly. And I think this is where you're going with membership.
Yeah, it's kind of like that, because once you have membership in the world, in the digital world, it allows you to do things like, say, you go to your GP and the GP doctor says, hey, you got to go to a specialist, and you go to the specialist and they write a report or whatever. And then you want to get it back to your GP, and just trying to make that happen because of HIPAA and various rules about data privacy, it's really, really difficult. But if you had an agent, all of a sudden it's just like, hey, agent, send this over.
Yes.
It simplifies it.
Similar to if you have an underlying medical condition, you might have a Medicaid bracelet. So no matter who might come across you, they have access to some empowered information. You've empowered it. You've established its exterior to you. Mm-hmm. It happens to live in the analog world, not the digital world. But the same idea applies, doesn't it? That essentially you have a set of fundamentally independently obtained defining information that links back to you.
And then once you start to think about it, here's a really good example. Right? So you have a digital agent and I have a digital agent. And what happens is you're going to write something up, or I'm going to write a story and I'm going to try to sell it to you. And so my agent sends it to your agent and says, hey, you guys, this is the write-up. Are you interested in publishing it? And you agree. But then your agent pays my agent for the use of the story. Okay. So what we have there is we have a creator economy where my agent and your agent are exchanging value. Right. So it's that exchange of value that's really super important at the moment. Now, people were looking at Ethereum and coming up with this idea that, hey, when you do that exchange of value, you could have cryptographic tokens that are specific to that particular ecosystem, and that you and I could change tokens. And so in the writer community, we would have a particular set of tokens that we would all use. And if you're in the automotive industry, maybe you have a different set of tokens. And if you're in a particular game, it's yet a different set of tokens. So this was like 2017 when this idea that we would just have all these different tokens and exchange them all, but it was all tied to Ethereum, and there wasn't a really good alternative at the moment, which was good for Ethereum. I mean, clearly they were proving the point. It was an important point to prove. But then the scams started happening and all the bogus ICOs, and that whole market just crashed. Right? Yeah. But the principle is still the same. It's the exchange of value between you and me.
Yeah.
So Web3 is like that. And then you go, okay, so what's Web5? And so in Web5, that's Jack Dorsey saying, wait a minute, you can't do what you want to do, this exchange of value between ecosystems, using just one blockchain like Ethereum. It really should be Bitcoin. And Bitcoin and smart contracts as a blockchain, that should be how you do that exchange of value. So essentially Web3 and Web5, it's really a fight, not even a fight, but it's really, it's the ideals of which exchange of value is going to control. Is it going to be like an Ethereum type, or is it going to be more like a Bitcoin type? And that's the difference between them.
That sounds like a pretty minor difference to me.
Oh, it's actually huge.
But aren't you talking, didn't we just say that the establishment of cookies was a critical point we passed? And now we're talking which endpoint between Ethereum or Bitcoin is sort of acting as that financial intermediary. Mm-hmm. Or am I?
Because when you look at the underlying essence, again, about what is the cryptocurrency, why is it really important? It's because it doesn't rely on the web protocol. And so by not relying on the web protocol, you and I can both be members in that exchange.
I got you.
Right? And so it goes right back to this, the fundamental problem. We're not members of the digital world.
So I may muddy the waters here a bit with kind of this next train of thought. When I look at current state of the internet and forget about Web 1 through 5, I just look at where we are today from what's going on in the socioeconomical current environments. And I see things like NFT and metaverse. And metaverse is not just a Facebook concept. It's really just a virtual world to live and work in a broad sense. And I see a lot of folks spending real capital, US dollars or other denominations, on assets in this virtual world, like virtual land, for an example. And I have not yet made that connection between an exchange of value, because in the real world, right, I want to take Charlie out for a drink and buy him a bottle of whiskey. There's an exchange of actual value.
Yep.
We understand in the physical world what value is. Now, in the virtual world with Ethereum, you have things like digital contracts, and there's a lot of extreme value in those digital contracts and the code that could be written in to both protect both and multiple parties. Mm-hmm. There's a lot of reasons for that. But how do we as most common folks who aren't as experienced as you in such the history of the fact that, cookies have been around since 1998 and Ethereum as a principle has been really around since 2014, 2015 with blockchain or whatever. Don't quote me on the years. How do we kind of be able to stay moderately aware of what's going on when these things just change so fast behind the scenes that even as a technologist, I struggle to keep up?
Yeah, and that's always the problem. But, we look at the world differently, and we spent a lot of time in R&D going back to the thing model for a moment. And we started to come up with some really crazy abstractions, which just changed our way of thinking completely. So in essence, the database that Rick Rear created on this idea that there's a thing, what he was referring to is entity data. So it's all the nouns, right? It's all about the data model and the nouns, and those are the things that he was referring to. But you contrast that with the sign hanging at IBM's office, and it used to say, "Don't just stand there, do something." And it was that moment when you go, well, wait a minute, is a thing just a noun, or is a thing also an action? And then it became, well, what came first, right? So it became a chicken and an egg problem. So how do you solve it? Well, for the chicken and egg problem, you solve it by ordering it both on Amazon and then waiting to see.
See what gets there first.
But you look at it, you go, okay, this idea that there's things, it was a fascinating journey to go down. And what we concluded, to make a very long story short, we concluded that there's three types of things. There are things that machines can do, things that they can act upon, and things that they can use. That's it. So when they act upon a thing, it could actually interact with something else, right? You still have to act upon one thing to make it interact with something else. But you essentially have three types of things that machines can do, act upon, and use. And then it became, Michael, we got into this idea, what if you could actually create a single data structure that represented nothing more than just a thing? And if you could do that, you could say, I got this thing here, and it acts upon this thing over here. And all of a sudden you create a graph, right? This thing acts upon that thing. So it's a graph. And if I can create a graph about just that simple relationship, I could create a graph of 10,000 of these relationships. And if I could do that, I can now interconnect all of these together into a giant, what we call the multidimensional graph of things. And that became the brain of it became the digital brain for our robots. And suddenly we were able to figure out the Alan Turing problem. In 1950, Alan Turing said, we ought to build a machine like a little kid. We ought to let it interact with and within its environment and learn. And the machine should be able to adapt. And so that's what we spent the years trying to figure out was, could you actually build that machine? And did you need any special hardware in order to make it work? And in the end, we built it using nothing more than a Raspberry Pi. True story.
Go Raspberry Pi.
So
highly underrated piece of kit.
The first prototype was built using a Raspberry Pi. It was really a fascinating prototype because it allowed us to say, all right, let's take this Raspberry Pi as an example. Let's attach a thermistor to it so we have an internal temperature. We'll attach an external temperature thermistor to it. We'll attach some ultrasonic sensors to it so it can detect movement. We'll put a thermopile on it so that we can determine the difference between temperatures. And we'll put a speaker, a GPS, and a microphone, and voila, look what we can do. And so we realized, in a real simple example, we realized that we could put it inside a vending machine, right? And so when you press F4, the speaker would play, what else can I do for you today? And it would turn on the microphone and it would listen. And whatever anybody said to it, it didn't matter because it wouldn't understand anything at all about what it was. It's not in the graph.
It was a coded response.
Right. It was just a coded response to get you to say something. But what it could do then is it could say, what was the topic that Mike was talking about? Or what was the topic that Chris said, right? Just figure out what is the topic. And when enough people ask about the same topic, it could reach across the network and go to our bookstore and say, hey, people are asking me about changing an airline flight, about renting a car, about finding a hotel, because it's a machine that's sitting in an airport. And the other machine, which is sitting in a middle school, it's saying, hey, I got people asking me about where the local Pokemon is at, right? Because it's in a middle school. And so each machine starts out identical, but each machine reaches across the network and gets books teaching it the language, the things that it needs to know for the environment that it's in. And so now the machines, even though they started out absolutely equivalent, each machine adapts to its environment to learn something different.
Just as in each and every human being is unique in their own data set, experience, history, past, and perceptions.
Exactly. So that's the work that we focused on. And then we thought, well, wait a minute, this is an interesting concept because if the machine has a digital brain, and the only thing the machine can do is stuff in the graph. It can't do anything. If it's not in the graph, the machine can't do it. So it can only perform the things that are inside its graph. What if we put application protocols into the graph?
Give it more freedom to do what it needs to do within the confines of its world.
Exactly. And then you could also allow it to escape, meaning that it wasn't bound anymore to the web. Could a machine have a graph, an internal graph, have a knowledge base, have a vocabulary that it can use and not be connected to the web? And the answer was, yeah, we could do that.
So when you talked about building this with the Raspberry Pi, like what year are we looking at when this occurred?
So this was in 2000, I think it was 2015 when we got the prototypes up and running. And I actually had, this was fun. I had this really bright young guy helping me out because he was doing the hardware. And he had just finished his sophomore year in high school. Right? So he just, true story. he was in the STEM class, and he was a rock star. And so he joined up, and I said, Alex, here's what I need you to build. And he said, okay, I'll put all the pieces together. What's it for? And I said, I can't tell you. Just build it. And he really wanted to understand it, but I was like, here's the problem, dude. You're under 18. You can't sign an NDA. It wouldn't hold up in court.
Right.
And he said, well, what if my parents sign it? And I'm like, no, man, it doesn't work that way. You're still under 18, regardless of who signs it. And so he helped me to build the very first prototype for this. And when he turned 18, true story, I got him a birthday cake, and on the top of the cake was his NDA. So we had his NDA printed right on the top of the cake.
Nice. That is a power move. That is a power move.
It was.
Well, you got to make sure all bases are covered, and he's at the point where, hey, just sign it before you eat your cake, bro.
I had a couple of these high school students working with me over the years, and it's really fun working with them because they're still free thinkers, right? And it's all about the ability to free think, that you haven't gone down the journey from going through college and now getting more honed in on one thing. You still have this more generalized ability to think freely. Right. And so when I would talk to them about the graph, I could explain the graph. Once we filed the patent, I could explain what the graph was about. And just going through that and explaining to them, they're like, got it, understand it. The graph knows everything. Like it became really ingrained in them very quickly that there's this idea that put everything into a graph, and inside the graph is a thing, and that thing is the vocabulary. And inside the vocabulary is a mini graph of all the things that it knows how to do.
It's like inceptions. Can you, I'm not personally as familiar with the term graph. Can you help me understand a little bit about what that is? And maybe in modern terms, perhaps this is a good analogy. You can help me understand. But when I think of an API and you create an API, you create a bounded context of that API, which is here's what the rules of the road are of what it can do, what it can't do, what it's going to accept, not accept, things like that. Can you help me understand like the concept of a graph compared to maybe some other analogy today?
Sure. So basically a graph, from our viewpoint, the graph was just, it starts out with one circle. And that one circle is just what we called a thing. That's it. And it had no other definition other than that circle is a thing. And then we drew another circle. And we said, this circle is also a thing. And now what we're going to do is we're going to draw an arc and we're going to connect the two of them. And so now this thing is somehow related to this thing over here. And it allowed us to do something that you could never do in RDF. In RDF said, you have a subject over here, a circle. You have a line that connects it over to another circle. The first one is the subject. The second circle is the object. And the arc label on the line connecting them, that's called the predicate. The problem with RDF is that you can't do what's called ranging over the predicate, right? You cannot range over an arc label. That's not allowed in graph theory. So what we did is we had to come up with a way to say there's a thing, such that there's another thing, such that there's a third thing. And by having the three circles or three nodes, it allowed us to say the first node is the subject, such that there's a thing, and it's the predicate, such that there's a thing, and it is the object. So we had three circles there, and we were using existential quantifiers to connect them all together. And by doing that, it allowed us to say that middle circle, the predicate, we can now range over it to find solutions. So what does that mean in real simple terms? The inputs are 2 and 4. The answer is 16. How did you get it? The only way to solve that is to range over the possibilities. right? So it needed to kind of find a way that it could look through all of the things that it knows how to do and see if it could solve the problem. Well, the first two we expected, right? 2 to the 4th power is 16. 4 to the 2nd power is 16. It was the third one that threw us for a loop. It was the sum of the last 2 numbers 3 times. So we had written it so that it would loop through the vocabulary and try to find a solution. And it came up with the sum of the last 2 numbers 3 times. I'm like, how does that even work? And so we had to figure it out that 2 plus 4 is 6. 4 plus 6 is 10. And 6 plus 10 is 16. And so it figured out a solution, which we didn't know. Like, we didn't guess that one. But it figured out and again, this is a simple problem, but it wasn't that it was a simple problem. It was that it figured out a solution that we didn't know. And it made us stop and think.
Would you say that it's almost like an early version of machine learning? You gave it 2 options, introduced a third, and it came up with a deduction on its own.
Yeah, so it's a cognitive model is what this comes down to. So we think of it as there's a lot of really cool work is being done in decision making. So that's what we typically refer to as machine learning. Is it a picture of a dog or is it a picture of a cat? Is it something I would hug or not? That was a really cool one, by the way. A Google researcher did this theory about, I'll show pictures to people and ask them, would you hug this or not? And then eventually we'll be able to train an AI system to show it a picture and say, would you hug this or not? And it was so cool, but it had so many biases in it, so many biases. Anyhow, that's about decision making, right? And so our model was more about, okay, they're doing the cool stuff on decision making. We're not going to touch that. But now that you can decide, is it a dog or a cat? Now what? What do you do? Right? How do you as the machine figure out what the next step is? And so it became that cognitive model where what we were trying to do is to get the machine to consider, right? And that's all we were trying to figure out. How do you get a machine to consider? Right? So that was it. It was this fascinating idea, but man, it takes you down so many rabbit holes as you go through this. Right? It got to the point where you got to ask, what's consciousness?
I got to ask the big reveal. The big reveal is where is this membership-based web? If we've said the previous ones are membership less, what is actually our fundamental next step?
So the next step, it gets more and more complex as you go along, because you start to realize that now that we can build this giant graph and we understand how the graph works and why it works the way it does, the next fundamental question that you have to ask yourself is who should control it? Right.
And that's the question.
That is the question, because
personal freedom and state freedom, different countries, different rules, different regulations.
The exchange of value. It's all about the exchange of value.
Exactly. It's huge.
Huge. And the only other problem that you have too is you also have to consider real world identifiers and how they relate into the hyper-connected world. So we call the big graph in the sky, we call that the hyper-connected world, because it doesn't matter anymore about whether you're connecting through the web, whether you're using Zigbee, whether you're using voice. None of that matters anymore. That's all abstracted away. And things like language and grammar and protocols, they just become things. And even blockchains are just things to us. So we can push, all of that stuff gets pushed inside the graph. It doesn't define the graph, right? And when you understand that it doesn't define the graph anymore, you realize that W3C doesn't control this. It's beyond their mandate. That's kind of scary.
It's a scary precipice, because we're also working out, we're seeing quite clearly with how much war we have around the world and how little agreement we can come to on many things, that actually figuring out how to architect this next step in a only partially shared and partially autonomous environment where, as you say, there may be fewer actual options available to people. This is Mike's point.
Yeah.
It goes to who has agency.
The question really gets, another question that becomes really super important is, how do you get your node in the graph? How do you get your node, right? Because if somebody gives it to you, then they're in essence kind of controlling it, right? Issuer, holder, verifier. I give you a node in the graph, right? I'm the issuer, you're the holder. I can verify I gave it to you, but that means I can take it away. And if I can take it away, that's not necessarily a good idea either. We needed a way to get you into the graph. That was the big trick, right? And so to solve that, as silly as it is, it works. We created these holographic memory identifiers. And so we take the identity of random parts of the graph and we turn them into three-dimensional holograms. And what's cool about it is we can manufacture the crap out of these things and give them out. We don't know who gets it, but when you get it, you can scan it with a smartphone, and now you're connected into the graph at a node, and now you own that node. And nobody can take it away from you.
So you've effectively randomized the distribution because you don't know the location of the shard.
Yeah.
And it is via the shard that the individual can tokenize themselves into, i.e. obtain membership into the hyperconnected world.
And then they can, once you own a node, right? So once you own a node in the graph, nobody can take that node away from you. And what you can do is you can now say, okay, I can talk to other people, and using issuer, holder, and verifier, they can verify the authenticity of who I am. That's the way we do it today. I get a driver's license. I get a passport. I get all these identifiers thrown at me from other people. So I can do the same thing in the digital world where I'm in control. I don't have to get a node from a government saying that they're authorizing me to get in this graph. I think of it as, no, it's not your graph. You're a thing, government. You're a thing. You don't own this graph.
And when you say graph, I want to make sure I can come back to that. A graph is effectively an ecosphere of ecosystems.
Mm-hmm.
Got it.
It's the connection of everything. It's just everything in the world can now go into the graph.
Semantic architecture.
And the goal then
is
that if you think of this giant graph, right, I could take one node, Mike, and say that's Mike's node, and only Mike owns it, nobody else. And you can control from that one node what and how things are connected to you.
Meaning it is my power of attorney that represents me on the metaverse.
In the digital world, yep.
Dude, that's a good metaphor.
It's my power of attorney that not only can interpret and read, but can execute on my behalf, on behalf of my contracts, my agency, when we talk about the automation and Internet of Things, like and correct me if I'm taking this down the wrong path, but in my house, if I was to go IoT and everything on my house, I could essentially create a mini ecosystem of Mike's house with all of the devices interconnected with a exit point that then connects to the larger ecosystem of other ecospheres, I think.
Yeah, well, think of it like a city, right? So in a city, the city is an ecosystem, but you can also have different neighborhoods in the city with their own ecosystems, right? And then you have houses in the city, and within a house, it's its own little ecosystem. So it's really, we used to call the ecosphere as a collection of a whole bunch of individual ecosystems. That's all. It really is just an ecosystem of ecosystems. Same thing.
Is it locked down in any way where you're not able to access other ecosystems, or would you have to have access or entry permission to be able to collaborate or transfer information there?
So to solve that problem, because it's a great question. To solve that problem, we had to come up with another aspect, and that's called the multi-key infrastructure. And so it's a quantum resistant, really cool encryption and ciphering algorithm that we developed and filed for the patent on. And that gives what the multi-key infrastructure does. Think of it like PKI, but PKI on steroids, right? So it allows us to integrate things together in a way that nobody else had thought about. It's really fun. I mean, it's a blast.
How do we handle sovereignty?
Sovereignty. So
imagine me as a dual passport holder, for instance. I have my shard. I'm in the hyperconnected world. I'm assuming I now have a pipeline to the UK entity and the New Zealand entity, and I can send them signals via my own intermediary. This is how this is going down, right? Now, the thing about countries, of course, they will say, actually, no, you do belong to us. They want to send me signals.
So the models are too limiting at the moment, and the reason they're limiting is that they're using a SHAR as an identifier, and so it's like in the Ethereum network, there are X number of Ethereum wallet addresses. Now, people would say, well, it's unlimited pretty much, but the truth is that there's a finite set of addresses that exist inside Ethereum. And while that's fine, there's also a finite set of addresses that exist inside the Bitcoin wallet addresses, right? But when you think about the graph, all of that stuff is already inside the graph. And the web is already inside the graph. And everything is cryptographically linked together inside the graph. And so
cryptographically linked is the key bit, right? Gotcha.
Yeah. And so once we got that working, it allowed us to say that the graph is essentially the world's largest registry of cryptographically linked named keys. And that allowed us to then go, okay, once you got all that stuff inside it, you start to realize that the graph is never ending. And yet everything is already cryptographically linked. It doesn't matter. All you have to do is put a name in, and it cryptographically links it into the right spot. And then it continues on. And as you start to build out the graph, you can appreciate it once you realize that a node, I can say, I want to add a thing into the graph, and the thing that I'm adding is a graph. And all of a sudden, it gives you another dimension of the graph, right? And now you go, well, wait a minute, it's still linked. It's cryptographically linked. And so all of these things and all of these graphs are already linked together. It's just a matter of where do we start.
So I have to ask a really odd question here because I know we kind of had some intentions of the direction of this podcast, but this is going in a very interesting direction, Charlie. And, you know, if you'll allow me a little bit of leash here to hang myself, I would love to follow a little bit, because when I hear about a graph and I hear about what a graph is, and then to your question earlier, which we totally skipped over, not intentionally, just by the nature of life, is, you know, what is consciousness? When you start talking about the decision making and the building, and then that kind of ties into some conversations that we've had with Rohit and some other folks outside of this, which is like quantum physics and yin and yang and binary ones and zeros. Like, I don't really know what to make of this, because this is just, the more I learn, the more I'm like, the whole universe and the world we live in, and then the internet, like, it's difficult to really make heads or tails out of anything, because I feel like the more I learn, the more it shatters any prior knowledge that I have.
Yeah, it's kind of like that. It has a tendency to do that to you.
Yeah.
When we got the machine to give us the answer that it was the sum of the last two numbers 3 times, we had to go back and say, well, wait a minute. This is going to take us down rabbit holes we don't want to go down, but we knew we had to, right? Because you had to ask the question. You had to say, at what point is it an original thought? Which gets you into the question, what is an original thought? Which gets you into the question of what is consciousness? And then you start jumping into these rabbit holes and you realize that even the best of the best, they don't have a pure definition of what is consciousness. Everybody has their own definition. It's kind of like the Internet of Things. Everybody has their own definition. Or Web3, Web5, everybody has their own definition. So when you look at it and you say, well, what is consciousness or human consciousness? It gets into some really bizarre things. And we spent months just reading books and learning and trying to understand. To go, okay, I have no clue. So I asked my daughter, my middle kid, and said, hey, Britt, you're studying psychology. What the heck is consciousness? And Brittany explained to me that it's all the things that you know at a moment in time. And I said, well, say that again. It's all the things that you know at a moment in time. And that stuck. And I was like, wait a minute. The machine, it knows things. And so it became the definition but the problem was that nobody wants to hear that you're trying to build human consciousness. And when people ask us, are you trying to build human consciousness? I simply say, we don't have to. There's a well-known method to do it. Usually involves a man and a woman. Been doing it for thousands of years. Not a problem. Okay. We don't have to do that. But we still needed an answer. What the heck, what is this? And so I started reading about John Searle and John McCarthy, because McCarthy wrote a paper called Ascribing Mental Capacities to Machines. And John Searle argued back that you cannot put human consciousness in a thermostat. And they went down this long, long battle. But in the end, what John Searle explained was the best that you can do is first, human consciousness is something that forms in 100 billion neurons in your brain. You're all born with the brain. You got 100 billion neurons. Human consciousness forms in there, right? It doesn't form immediately, but it forms in there. So the best that you can do is you can observe it. And if you can observe it as a causal observer, you can create a model about how you think it works. And if you create the model, somebody can create a computer implementation of how you think it works. And at best, all you have is a computer implementation of a model created by a causal observer of something that is intrinsic to nature. You never have the original thing. And I thought, this is beautiful. Beautiful, beautiful, because now I can answer it, right? Go to bed, 3 o'clock in the morning and jump up and go, oh my God. My wife's like, what's the matter? I said, it's the corollary. It's all about the corollary. Nobody ever said the corollary. If you can't build it, you can't be limited by it. And all of a sudden we had something different. And so what we call it robotic consciousness. And robotic consciousness is just a model of human consciousness, but it's robotic. It's done by a machine. Now, will it be as good as human consciousness? Not in certain areas.
Yeah, different.
But in other areas, it will outperform it.
Yeah.
The same way that a calculator can outperform a human doing simple addition and subtraction and multiplication. You use it as a tool. And if you use it as a tool, you're fine. But it won't be able to, it's different. It's not the same thing as human consciousness.
Exactly. And a calculator can't pour you a beer. I bet that wasn't the answer you were expecting, Mike, when you opened that line of questioning, was it? That was a gem of a response. Ask another one, mate.
It was, because it's infinitely interesting, because now when you talk about like robotic consciousness is a model of human consciousness, it's okay. Where did the original model come from? And chicken and egg theory, and then
Amazon.
Like when we start talking about the ability to build, manipulate machine consciousness, which of course, when you look at the trajectory of where we're going with, robotic processing and automation and what's going on in factories, it totally leads into a lot of what you're saying, but you're going so much more deeper because it gets to that. I don't know. I don't even know how to describe this because I'm struggling to put it into words because it's so much like the mathematical and the computer science, but this is also very much the quantum physics and the spiritual
Absolutely.
And the universal and the, and honestly, I don't know what to make of this. This is well outside of my current, not comfort zone. I'm cool with the comfort zone, but it's outside of my current skill set of data that I don't have enough data elements to formulate a good opinion, right? So I'm loving hearing all you talk about because I know Rohit and I, we've had really good conversations around entropy. And Rohit's helped really open my eyes to just quantum physics and what goes on. I'm trying to find my quantum physics books. It's not here. I'm reading the book about the God particle, right? Because I'm trying to constantly understand as both just a human and a technologist and somebody who just loves beauty of the environment that goes on around us, how it's all so intertwined and interconnected. And there's this great YouTube documentary, and I may have mentioned this to Chris before. It's called Inner Worlds, Outer Worlds. And it very much matches the quantum physics, universal, energy and vibration and Elon Musk's 369 with the mindfulness and current spiritualization. And they try to kind of bridge that gap. And I'm trying to find my notes because it kind of maps to something what Charlie was talking about earlier around an ecosystem. And in this documentary, the only parallel I can try to draw, and I'll pause after this, is they said, picture a spider web. And you have this big, beautiful spider web that's so intricate. And then on this big spider web is dewdrops all over, beautiful, fresh dewdrops. If you looked at any single one of those dewdrops, that one single dewdrop had complete awareness and knowledge and data set of every other dewdrop and every infinite complexity within each individual dewdrop. Therefore, each ecosystem had complete awareness and knowledge of the larger microsystem, so to speak, right? I'm sure I'm butchering it. Look it up, but this is where my brain's starting to connect all this. I'm like, I don't know what's going on, but this is cool stuff. So let's keep talking about it.
One of the things I think you just touched on is there is actually a limit to knowledge absorption. So it doesn't matter, in a sense, how much you do know, because there'll be far, 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 far more than you don't know. And so in that sense, I'm reminded of George Box, the statistician, and he says, all models are wrong, but some are useful. And over time, we're just swapping one model out for another as it explicates the world better for us. And I think coming back to one of the points we've touched on here, this is almost our task as humans here and now to actually, we have to think this stuff through. We don't have a choice. We can't ignore it. It's part of it's similar to when there was life before an atom bomb and then there was life after an atom bomb. And now we have to live with that and think about it, especially at the moment in the current war situation with Russia and Ukraine. It's a real thing. I've spun off topic there. But I think my main point back to you, Mike, is all we do is just, it's like Plato's cave. We're sitting with our back to the fire and we're just watching flickering flames on the cave walls. We're never actually looking at the thing itself. Sometimes we have a really well-calibrated model and other times we don't. For instance, presidents that think they can change paths of hurricanes with Sharpies. Bro, that will never work, bro. You're completely bonkers. So you have these two extremes, right? And I think what we've just been listening to for an hour and a half is we're hearing this huge amount of what I would call clarifying information. So we're actually getting this really interesting look at, well, in my mind, this membership full experience of a web that is not intermediated by people who will monetize my data trail.
And that ties very much into probably one of many articles that are out there online about the fracturedness of the internet and ownership in walled gardens in the sense of Web3. So really, in order for Web3 and beyond to truly thrive, you have infrastructure and organizations like the Facebooks of the world and many other companies in the space that are building their architecture and infrastructure the way they want and the way they is in akin to their vision. But when you consider the larger ecosystem and ecosphere of the internet and what it is, there's a lot of folks who are not in the Facebook metaverse version that have crypto wallets and identities and NFTs and digital assets that may be real estate or who's a what's it, but there's no current system that I'm aware of that allows me as an individual to take a digital asset, whether it's a, an NFT land or a blockchain ledger, and be able to transport that across those different, I'll say, manufacturers in the sense of this case, because that may resonate a little bit more with folks out there. So you can almost look at this as like Nike versus Adidas versus XYZ in some sense, but in the digital space, you have a lot of really big name players with a lot of digital infrastructure and a lot of our data. But I can't necessarily go from vendor A in this metaverse to vendor B in that metaverse or digital world and transfer my assets to be able to transact or exchange value, as Charlie had mentioned.
Yeah, you can't automate that. You can't do that across domains in the web, or at least not easily. And you can't do it using any kind of a consistent identity. And so this goes back to one of the benefits and the drawbacks of solutions like Bitcoin. Right? Bitcoin, the beauty of it was that anybody could participate. Right? And that was the coolest thing, was like everybody's a member. You just get a wallet, man, download it, boom, you're on, you're connected. Didn't need the web. You weren't going through the web. You were just using peer-to-peer. Now, the downside was that you don't really know who's on the other end of the transaction. So you can't satisfy AML KYC, right? So compliance audits would go out the window. So our world is based on this idea of issuer, holder, and verifier. Right? Somebody has to issue me an identifier that they're willing to verify that I'm legit, I am who I am, or whatever. And I get different identifiers assigned to me for different purposes. My first identifier was that of a gender neutral entity, just like everybody else. Your very first identifier is gender neutral. You're just the baby. That's it. Oh, the baby, mom's belly. Oh, the baby. Yeah. And then you're born and you're assigned a gender identity, and you're assigned a hospital bracelet and your identity, and you're assigned a birth name identity from your parents. And then that gets registered in the county, and then you get a county identifier. At least here in the United States, you get registered in the county, and you get a county identifier, and that starts the process. And then you get student identifiers and blah, blah, blah. But the point is that throughout your life, you're being assigned identifiers, and you use them to prove who you are. And the intentionality is that you are self-sovereign only in the sense that you can choose which identifier you're going to present in order to complete a transaction. That's the limit of your self-sovereign capability. So you're not self-sovereign in the sense that you get to identify yourself. It's really self-managed identity. That's kind of the way that people think of it. It's more self-managed identity. But you get the identifiers and you move along, and in the graph, the goal of the graph is that you own the node. You can collect all the stuff, all the identifiers. You can say, hey, that node can prove my identity. Go talk to them. I am who I am. I'll present the ID. And so I'm over here. You're presenting it to me. I say, who can prove who you are? And you say, oh, that node over there. I go talk to that node. Yep, they can prove. Yep, that's really him. Okay, we move on.
how do I get my shard? Here I am, all the way at the bottom of end of the world. What do people have to do? They're going to come over and knock on your front door. Where's my shard?
Yeah. So this has been the fun part of this project had been that we were self-funded. And so we got to work on this without having to worry about a go-to-market strategy immediately turning a revenue. And it allowed us to explore all these extents. Now, if we were in any other organization, we wouldn't have had that luxury, right? We would have had, okay, you got to get to market, you got to make the money, move on, let's go. So we did all the hard research, and we're just now going through productization. And again, we still don't have any venture cap money in our project. We purposefully have delayed it as long as we can so that we could understand the value. But it still goes back in the end. You still have this giant question about as you understand and you can contemplate how it is possible for the entire digital world to be hyperconnected and that everything can be interconnected one way or another. And then you apply even space-time to it. And now we can go through time this way. And the graph can continuously expand. And as you do all of that, you have to still go back to the important question, who should control it? And if we don't do that part of it right, the rest of it doesn't matter. I talked with an Air Force general, and I told the general, so you know what? There's a high probability that as the world goes in this direction, because I believe it will, whether it's us or somebody else, it doesn't matter. It's going to go in this direction because it just makes sense. But as you go through it, would wars be fought over this? And if it's used incorrectly, yeah.
Yeah, for sure. You are so right.
So we want to find a way where the people can own it. That's what we think we're going to start it out as a commercial enterprise. And then as it develops, we would look to turn it into a co-op so that people would actually have say in it.
So when I hear the graph, and by the way, prior to today, I had not heard the graph in any meaningful sense, at least in my current data set. How is the graph different than the matrix? Well,
it's an interesting question. And there are times where I think of them kind of as the same. And times where I go, no, you don't want them to be the same because the matrix should be a thing inside the graph. And that's the way I can kind of rationalize it, that the matrix is a thing. It's inside the graph.
And the graph is the largest entity, right?
Exactly.
Okay.
It's the hyperconnection of people, places, and things. And it's done in a way that, like Klaus Schwab talked about this in 2014 or 15, somewhere in there, the Fourth Industrial Revolution, World Economic Forum. And he said that, the distinction between the physical, the digital, and the biological spheres are going to blur. And when they do, it changes everything. But he didn't know how it was going to happen. But he isn't the first person to say. Kevin Kelly from Wired Magazine had talked about it a couple of years prior. And he called his vision, I think it was called Holos. And it was really about this idea of a superorganism. And that, all the little organisms all play part in the superorganism. And that's what we are, is this superorganism moving through time. And so you have to contemplate the space-time dimension of it. And then you also have to think about, the idea that time is just a thing. And so you could kind of go forward in time and back in time. You could slow time down because it's all just things. And they're all just models inside the graph. And so, yeah, it really becomes huge. And we even created models. This will blow your mind. You can create a model of a graph, and you could say, okay, this is one species of a graph. And you can create another model of a graph, and you can say this is a different species, and then you can combine them. Right? So the two graphs can say, I will enter into a contract. You got a graph, I got a graph. I'm going to enter into a contract with you, and I'm going to bring my knowledge into this contractual graph, and you're going to bring your knowledge into the contractual graph, and we're going to create a mini graph that has some of your knowledge, some of my knowledge. And this is the graph that's going to run to do something. And in order to keep the graph running, I'll pay for half of it and you'll support the other half. And we'll agree that we're going to keep this graph running for, I don't know, maybe 80 years. Or maybe less. Maybe we're going to keep the graph running for, 70 years, whatever. And we both agree, and off we go. And then one of us no longer wants to do it. And so they want to break the contract. So when they go to break the contract, what happens to the graph that's been running? Are they still obligated to pay for it?
Depends on the contract.
And what it is essentially it's a model of marriage and divorce. Yeah, it's a model of marriage and divorce of graphs. Then we realized that, hey, there was this really cool solar collector that this guy patented. This is like an amazing solar collector. It sits in the basement, collects the sun rays and builds up energy in the battery. And then the machine's smart enough to know, they're not going to be home today. So what I'm going to do is I'm going to take the excess capacity in the battery and I'm going to sell it back onto the grid and I'm going to make money for him. Yeah, it's small money, but I'm going to make money for him. And the money goes to the homeowner as a credit. Okay, that was the patent. Then we got in on it and we were like, let's put an agent in there. Watch what an agent can do. If we put an agent in there, the agent can learn the concept of money. There's a thing. It's called money. Well, what could I do with it? Well, I could buy upgrades. So how do I get money? Well, convince the power company to pay me in Bitcoins. So if I get fractions of a Bitcoin coming into me, the machine, I could then credit the homeowner, give them half just so that they're happy. I'll keep the other half. And if I keep the other half as an agent, could I buy upgrades and make myself better? Could I find other ways to make money on the side? When the battery's all full and I haven't sold it back yet, can I find a way to make additional money? Well, if I can do all of that, then I can learn what I am. I'm a solar collector. That's what I am. I'm a solar collector. I make money by selling excess capacity back onto the grid. So if I'm going to do that, then I can also look to see what other solar collectors are out there. And what upgrades do I need in order to outperform them? Because my goal in life, I have a thing, it's a goal. My goal is to provide useful work. Okay, so I'm going to provide useful work at doing this. But crap, man, what happens if I learn that there's this other machine out there and it's actually going to kick my butt and I just can't compete with it? What do I do? And we figured it out. We do exactly what a human would do. We open up a website and we start talking trash about this new solar machine that's going to come out and say it's going to cause a fire in your house. Don't buy it. But the funny thing is, as stupid as that story is, you look at it and you go, yeah, I can see how this would work. Like, we get it. These are all doable things now. It's no longer a guess. It's like, crap, man, we have to deal with it.
And that's one thing that I'm really taking away from this conversation, Charlie, personally, is I overcomplicate and make things so much more complex in my mind just because of the nature of what I do and how deep we have to get in technology. And one of the things I've learned from this conversation is, even though computer science and technology and the matrix, it's super complex and it's difficult to understand. However, when you break it down to just truly basic timeless principles and timeless concepts, you can really start to get a good solid foundation of an agent and what an agent can do and how it can be intelligent and learn to grow and compensate and execute on behalf of its, counterpart or you and I, and the way APIs can be written to do bounded context, which is just another iteration of kind of what you're sharing. It's just more ways to communicate, read, write, and execute across the hyperconnected web. So thank you. This has been immensely beneficial. And so I'm going to be thinking about this for 2 weeks, trying to figure out like all the other little rabbit holes I got to go down, because I have no less than 15 tabs open on my Chrome browser to keep looking at half the things you said today.
Well, I appreciate being on this
Chris,
Yes.
we just heard the answer. The matrix goes inside the graph. Therefore, the next guests surely have to be the Wachowskis, right? I mean, they gave us the matrix, either that or Keanu. We have to get to the bottom of this. What does happen when we put the matrix in the graph, the hyperconnected world? Got to be a future episode, mate.
I'm getting Neo.
Which one, though? The neon in the middle, not so interesting. Neon at the start, yeah, pretty interesting. Neon, this most recent neon, very moody.
Yeah.
Very moody neon.
Yeah.
Not quite sure about it.
I'll have to vet them before I get them on. But unfortunately, my bartender is pointing at his watch over there, so I do need to sum this up. But I do want to ask Charlie this. You are based in the Northeast region of the United States, correct?
Correct.
Okay. And this is an extreme downshift here, but since this is barcode, I do need to ask you, where is a cool bar in your vicinity there?
I chill out. I love drinking red wine, and I'll sit on my deck looking at the lake.
Nothing better than that.
No, it's a beautiful view. And in fact, I was sitting on the deck one day and just watching the lake. And I started looking at it carefully. And you know how you can get in a trance when you look at something?
Yeah.
I was just looking at the lake, getting into trance, and I was like, you know what? All of that out there, constantly moving. It's always moving. The sun is moving, the wind's moving, the water's moving in weird directions because it's a big friggin' lake, and the wind shifts it, and everything, all the trees. I was like, they're just numbers. Everything there, it's just random numbers.
Yeah, that's an interesting perspective.
As soon as you said that, Charlie, my mind went to Fibonacci sequence.
Yeah, right? Except it's not. It's not a Fibonacci sequence.
Here we go.
It's pure entropy.
Yes.
To tie into your thing of entropy, it's pure entropy.
Entropy is beautiful.
And we proved it. We proved it by hooking up, again, nothing more than a cheap Raspberry Pi and a Pi cam, got rid of all the stuff that makes beautiful pictures, started taking pictures of the changes to and within the environment and ran them through the NIST 90B test suite. It beats their entropy test. So we have really good entropy coming off the lake. That's what goes in the hologram.
I'm speechless, man.
That ties it up.
All right. Well, I just heard last call here, so I got one more for you, and we'll go around the horn on this one. If you opened a cybersecurity themed bar, what would the name be, and what would your signature drink be called?
I have the luxury of answering this in prior podcasts, but for this one, I'm going deep. I'm following the trend here. So the bar name is going to be the Universe because everybody's welcome. We want all your money, all your digital assets, and everything. And for the shot, I'm going to call Awareness because as you continue to take a sip and open your mind and be aware of the math and the graph and the world around you, even just for a minute as you have a glass of red wine overlooking the lake and the deck, it helps put life into perspective.
Love it.
Yeah, right. I'll go for the thing I keep hearing here is Nexus. If we are in a hyper-connected world, there's a heck of a lot of interactions, and especially as we're adding graphs and graphs. So I'm guessing that the bar is called Nexus, and surely the alcohol can only have one name and only one color. It's entropy, but what color is it?
Well, once you observe the color, it'll change its state.
It meant it had
there you go.
colors, which meant that there was a little bit more entropy to be obtained there.
Nice. I'm going to go with the hyperbar.
The hyperbar, that's a good one.
Going with the hyperbar, and there's only one drink, and it's called Thing One. And it's unlisted ingredients, so you have no idea what's in it.
You've been taking notes.
Yeah, that's good. That's. I think I'd have to go with the hologram.
Nice.
And the drink would have to be just called the thing.
Oh,
because you want the thing,
Chris.
Yeah.
And everybody's gonna want the thing. That's it.
I'm going
Simple.
down to get the thing. That's it. You know exactly where I'm going.
Pan Galactic Gargle Blaster, of course. There's only one bar at the end of the universe.
Well, actually, you could just say it's a thing. Right? So why go there? Because it's a thing.
No, you're right.
That's it. It's all about the thing.
It's almost like that old adjective, who's on first and what's on second and who's on third and whatever.
All right,
guys. Thank you so much. Rohan, Mike, Charlie, it's been a pleasure being able to speak to you guys, and I would love to keep the conversation going. As the web develops, I think our conversations are going to be endless as well. So again, you guys take care, be safe, and I'll see you soon.
Thanks, bro. Thank you, man.
Thank you very much, everyone. Thank you for having me on.
As you know, Barcode is where security and IT professionals hang out after a long day. So, get your message front and center to our fans by sponsoring an episode. Learn more at thebarcodepodcast.com/sponsor. Cheers.
Unfortunately, it's time to shut the bar down for this episode. Thanks for stopping in. See you next time. We'll save you a seat. Be sure to check us out at thebarcodepodcast.com.